All right, let's read this first. It says the graph of f is given here. Oh, no, the graph of f given here consists of two semicircles, so that and that are semicircles, and one straight line segment. Let g equal this thing, which has f inside of it, from 0 to 10. So here's 10 right there. So x is from 0 to 10. Because we have a graph, I want to make sure I label it because sometimes we forget what we're looking at. Okay, so this is the graph of f. We put it right there, we put it right here, it doesn't really matter. Just as long as you label it, you know that it's f. Okay, what is g of 0? You see, what some people would do is they would see, oh, g of 0, then they would look over here at 0 and they say, oh, the answer is 0. No, that is the graph of f. What is g of 0? So to find g of 0, we're going to have to plug it into the integral function. So it looks like this. G of 0 equals from 1 to 0 of f of t dt. Alright, so we're going from 1 to 0, which is backwards. Normally the bottom number is the number on the left. You see, right now we're going from 1 backwards to 0. That is backwards. So if we're going backwards, we have to look at the area that is under the curve as the opposite. Right now it's the positive. But if we go backwards this way, we go 1 to 0, then that is going to switch the sign of that area. So another way we can write this is from 0 to 1, and if we switch it, we got to change the sign of the integral function so that it says negative in front of it. So this right here just says what is the area underneath the curve from 0 to 1. So let's do that. That's a semicircle, so we know that the area of a circle is pi r squared, but since it's only a quarter of the circle, we're going to divide that answer by 4. R. What is R for our circle? Well, for this circle right here, R equals 1. So we're going to plug 1 into that. So instead of R, we're going to plug 1. 1 squared is just 1. So this is going to equal pi over 4. But let's not forget our negative that goes out in front of it, and that ends up being our final answer. So if we plug 0 into g, we get negative pi over 4. That's the answer for that. Now let's look at the next problem. The next problem says, for what values of x between 0 and 10 does g prime fail to exist? G prime. Now what is g prime? Hopefully you're thinking, or you know the fundamental theorem of calculus part 2. We're going to take g, which goes from 1 to x of f of t dt. And we're going to take this whole thing, we're going to take the derivative of this with respect to x. When we do that, what the fundamental theorem of calculus says is that if you take the derivative of that, it cancels out the integral, essentially. The 1 on the bottom you don't care about because that would make a constant in the area function. And so our result would be the x plugged into the function, so we just have f of x. So this means that the derivative of g equals f of x. Oh, let's relabel our graph here. We can say that this graph is g prime or it's f. So it's g prime or f. Okay, now let's read our question again. It says, for what x does g prime fail to exist? And so I'm looking at this. All these numbers right here represent an f, or they can represent a g prime. And I'm looking at my function, and it looks like this function is continuous. There's no holes. There are no holes. There's no asymptotes. So that means that for every x value between 0 and 10, g prime exists. So because I stated this, I could then say, therefore, g prime exists for all x's. X is less than 10, less than or equal to 10, greater than or equal to 0, because g prime is continuous. Alright, cool. Let's look at the next one. A, B, C, D. A, B, C. Okay, now we're on C. C says, for what values of x from 0 to 10 does g double prime fail to exist? So let's think about that for a second. If we found g double prime, that would be the same as finding f prime. Because g prime equals f, that means g double prime would equal f prime. So if that's true, since f prime represents slope of f, then we just need to look at this, the slope right here on this function. Where does the slope not exist on this curve that we have? Well, we know that the slope does not exist at holes, points or cusps, or vertical lines or asymptotes. So we have at 2 and at 6, we have no slope. So to answer our question, g double prime fails to exist at x equals 2 and x equals 6. So actually I'm just going to say comma 6. Now I'm going to say because slopes, or let's do this. This sounds better. Because functions are not differentiable at vertical lines and points. Or I suppose I probably would just be able to get away with saying because the curve shown is not differentiable at 2 and 6. This would also be important to state, showing that you know that f prime is equal to g double prime. Alright, last part, D. I wonder if I'll have enough space down here. D says, how many solutions are there to this? G of x equals 0. For all the x's between 0 and 10, justify your answer. Okay, so that, because it says g of x equals 0, we know that to be an x-intercept. So this question is essentially asking how many x-intercepts are there for the g function. Remember, we're not looking at this. We're not looking at this curve right here. This is not the g function. This curve right here is the f function, or g prime. We're looking at this. This is the g function. So how would we show that there are so many x-intercepts? Now, it's very important that we justify our answer here. Otherwise, your answer would not count. This is this concept that we're testing on this question is known as the mean value theorem. Mean value theorem states that if f is defined, if a function is defined and continuous on an interval and it's differentiable on that interval, then there is at least one number that you can plug into the function that will equal, or that will be between the two endpoints. A more specific version of the mean value theorem, MVT, is Rolle's theorem. Rolle's theorem is the same thing, except Rolle's theorem is specifically talking about x-intercepts. So let's start with 0. Starting with 0 because 0 is at the beginning of our interval. What is g of 0? So at g of 0, actually, let me stop for a second. we know that this equals negative pi over 4, but I want to explain like where we're going, like how, like what I'm thinking here. So I'm going to erase everything above the D and then give you guys like a visual. Here's a visual of the MVT. MVT says if you have a function, that gives you a point. Here's my function. It gives you a point right here when you plug in this x value, and then when you plug in this x value, you get a point up here. And you know that f is continuous and differentiable. You know that somewhere between these two x values that there's going to exist an x value. Actually, this is MVT, but it's also Rolle's theorem. This is Rolle's theorem. If you have a negative number and then a positive number, between those two numbers, you're going to find a number that'll give you 0. an x value that'll give you 0. So that's essentially what we're doing. We're trying to find a negative number and a positive number, and then we can say, hey, because we have a negative number and a positive number here, we have an x-intercept between these two numbers. So if we start at our leftmost x value, which is 0, we see that we get a negative number. So here's a visual. This graph doesn't make any sense. This graph is not accurate, okay? I'm just going to say this is the graph of g. At 0, we have a negative number. We're going to say this is negative pi over 4. We could be exact right there because we know what it is. And then we look at the g prime graph to try to explain what's happening to our g function. And it looks like from 0 to 2, the g function is increasing the whole time, because from 0 to 2, g prime is above the x-axis. If g prime is above the x-axis between 0 and 2, we know that the g function has a positive slope between 0 and 2. So that means from this point right here, we're going to be increasing all the way until we get to 2. You see, right when we get to 2, the behavior changes. G prime is below the x-axis, so that means the slope for g after 2 is going to be negative. The function g will start decreasing. Okay, so if we know that we're supposed to be increasing from 0 to 2, what we really need to know is what's happening at 2. Do we get a positive number or do we get a negative number? Because if we get a positive number, boom, we have an x-intercept. If we don't get a positive number, then we don't have an x-intercept. I mean, there could be, but we don't know. Like, the line could go like this, and we could have 2 x-intercepts in there, but this can't happen actually, because this part of the function g is decreasing, but we know that the whole time between 0 and 2, the function is increasing. Okay, so let's plug into 2 and see what we get. So we got g of 2, which would be written like this. We're going from 1 to 2 on this function right here. So we're going to find the area between 1 and 2. And if we look up here, because we already found this part right here, then that means, I mean, we're going to know what this area is right here because it's a circle, and that's just another quarter of the circle. So from 1 to 2, we know that our area is pi over 4. Positive pi over 4, actually, because we're going forwards. So we got a positive number at 2. So we plugged in 2 to g, we got a positive number. That means we have a point somewhere up here. I don't know exactly where. Boom. I don't know if it's curvy, I don't know if it's straight, but it doesn't really matter. All that matters is that we have an x-intercept between 0 and 2. So I'm going to say, therefore, there is, oh, nice is 1 x-intercept between 0 and 2, because g is increasing between 0 and 2. Now I don't have to state this again, the negative pi over 4 and the positive pi over 4, because it's kind of implied. And whenever you have justify, that means they're also looking at your work to see if you understand what you got. Okay, now we have other intervals to check. The function g is decreasing from 2 to 6 the whole time. So I want to know, while my function is decreasing, do I actually get past the x-axis? Do I get another x-intercept? So let's put the number 6 right here to have our visual. I want to know if we're going to have a point above the x-axis, in which case we would not be crossing the x-axis, or if we get a point below the x-axis. So do we get a positive or a negative value when we plug in 6 to g? So I'm going to plug 6 into g right now and figure that out. Okay, now if I plug 6 into g, I'm going from 1 all the way to 6 right here, and I'm supposed to find the area between the curve and the x-axis for that and for this. Now I know that this area that's below the x-axis is going to be negative. So we have a positive pi over 4 right here. What is the area of this going to be? Let's see. We have an what did you call it? The radius. So we got pi over 4 plus the radius is 2 squared. So that's pi r squared divided by 2 because it is half of a circle. It's not a full circle. And pi r squared is going to be 4, but then you divide that by 2, it's going to be 2, so this is going to be 2 pi. So we have, oh, and negative, that's right, because we're below the x-axis. So we have 2 pi plus pi over 4, which is going to result in a negative number. Let's go ahead and clean this up over here. We have pi over 4, and we're going to subtract from that 8 pi over 4, because that's the same as 2 pi, and we get negative 7 pi over 4. Oh, boom. So we know we get a negative number. Alright, so I'm just going to connect that for a visual here on understanding this concept. We have another x-intercept. Now I'm going to say the same thing. I will say, therefore, there is a second x-intercept between 2 and 6. Because G is decreasing between 2 and 6. Alright, now we only have one more interval to check, and that is all the way to 10. So I got to plug in 10. So, oh man, I'm running out of space. So let's go G of 10. What do we get when we plug in G of 10? Well, we have pi over 4 plus negative 2 pi. Okay, so that's the area right here plus the area right there. Now we got to find the area right here of this triangle right here. Ooh, nice triangle. Okay, the distance right here from 6 to 10 is 4. The height is 4. I know that because of this point right here. So we have plus 1/2 base times height. So this is going to be 2. 2 times 4 is 8. So I have, I know this is going to be negative 7 pi over 4, and I'm going to add to that 8. If I put 8 over 4, this top would be 32. And I'm just estimating here. If I went negative 7 times 3, that would be negative 21. But that's, you know, approximate. And if I add to that 32 over 4, that's going to be a positive number. I'm not so worried about multiplying 0.14 to 7 because that's going to be a really small number. That is not going to make this bigger than 32. So that means we got another positive number. I guess a more academic way to write this would just be to say this is greater than 0. Therefore, we have a third x-intercept between 6 and 10 because G is increasing. Oh, I didn't state that earlier to you guys. You see how G prime is above the x-axis the whole time between 6 and 10? That means G is increasing between 6 and 10. Alright, so we got another positive number. If we go all the way up to 10 right here, we got a positive number. Oh, that's nasty 10. We got a positive number, so we're up here. Boom. We have 1, 2, 3 x-intercepts. Done.